Alright, so this is the group work we did over one way to modify Sona. And it starts out just by a quick little practice problem here. We have a 2 by 4 grid, 2 rows, 4 columns, and a 2 by 3 grid. So we expect this Sona to have 2 curves because the greatest common divisor of these two numbers is 2, and that bears out. So there's the first component. I'm going to do the second one in red because it'll be helpful later on when talking about some of the problems. So we have 2 components. Over here, 2 and 3 are relatively prime. That is, the greatest common divisor is 1. So we would expect this to be monolinear, just one component. That's the case. So monolinear, and we can call this 2 linear. Now, question 2 involves modifying these Sona, and we'll see some examples in class where this sort of extension was done. One helpful way to carry out the plated algorithm is to imagine that you have some walls here so that when you get to the corner here, you know what to do. So let me show you what I mean by that. So I start, and then I get over here, and however you want to think about it, again, using the bouncing ball analogy, it's bouncing off various walls and then returning to the previous grid of dots. Here's one component. Here's the other component. So it's still 2 components. And we'll talk about understanding why that is after we do all 3. So same thing over here. We're adding 1 dot. That's all we're doing, is we're adding 1 dot to this 2 by 3 that was monolinear, and it's going to remain monolinear. So this is still mono, this is still 2. Let's try adding 2 points. We're adding 2 points to the original Sona, to the original grid. How does this affect the number of curves or components it takes? So let's see. And one thing to notice here is this black curve is the same black curve up here. Same black curve here, right? There's a little bit of an extension on this black curve. And now there's an extra extension on this black curve. Color coding these can be pretty helpful when we're trying to find patterns. As a bunch of you have said, it's pretty hard to tell whether something's monolinear or otherwise just by looking at it. The lines all blend together, which is, I think, maybe part of their beauty. So, whoops, I goofed here actually. That happens. Oops, that was too many too. So not that one. Alright, so that's what that one should look like. One more set here. Again, notice that black curve. All we're doing by adding another point is really extending and twisting this. Right? So we're just adding on another little loop of this same piece. Then here is that. And then over here, right? So each time the monolinearity was preserved, over here the number of curves was preserved. Now how do we try to understand this? just realized I wanted a prop. A good one here. So consider a little piece of string here, and look up here at this black curve. All right, we have this little loop which encapsulates, or rather, orbits, as one of you had mentioned, around this point. Well, what happens when we add another point? Well, we're really just taking this and then adding another little loop on, right? So we're not adding any paths. This black path is still the same black path. We're just making it a little bit longer. Each time we add a point, we're just stretching and twisting it. We're not going to change the number of curves by taking that single black curve and stretching and twisting it. And another way to think about this is, suppose I took this monolinear one, and I'll do it in pencil. So this is monolinear. It would still be monolinear if I did some weird doodle over here. All right. This wouldn't affect the monolinearity of this. All that's important is that when I leave the grid, that I come back right where I used to go, right? So the idea is we're snipping this path and then doing something and then coming back. So hopefully this method of modifying makes sense. And we'll see a bunch of examples where this was done to create legs or necks or whatever on various Sona. Oh, also this, I guess I wasn't done yet. Down here, this is just another way of adding points, and again the method is the idea is to drive home the fact that we're not going to change the linearity of a design by adding a row of dots. That's just not going to affect it in any which way whatsoever. Actually, I think this is a hammer. This, and now that I think about it, this, in fact, this little Sona here might actually be an example of one. Okay, let's turn the page. So this bit here is what I talked about, sort of explaining the idea that if you have some Sona and you're adding a bunch of points, that's okay, because all you're really doing is taking a little diversion. You're on a path, you stretch it out, and then you're back. Say, you might want to contrast with break lines. Break lines, if you think about it, let's do a little example here. Oops. Break lines snip. If you think about what a break line does, as you're coming along this curve, you're told, no, stop. Go on another piece. Don't continue the way you're going. And that can affect the outcome. All right, so here we have an example of where that break line resulted in. Now this is I went from mono to two linear, just two curves. Okay, so down here what we're doing is we're actually taking a 2x4 and then a 2x4, and we're gluing them together on a point. So let's see what that looks like. And again, you might find it helpful. I know I still do, to put in some corners there. So Right, there's one curve, and then, whoops, there's another. So now we've gone from 2 to 3. And think about why that happened. Previously, we had a Sona with 2 components, black and red. And then we took another Sona with 2 components, black and red. And then where we glued them together caused one of those previous components to meet up with the other one. So we're not getting 4 components, but we are getting 3 because this black sort of V shape here and this inverted V shape, they're in no way connected. So 1, 2, 3, and then this other potentially 4th component gets joined with this other one. So we only have 3, but we can increase the number of components. What happens if it's monolinear? I have to make 2 videos here. This is getting long. I'm overly chatty. So you could do this is monolinear, and it should make sense. What we're doing, again, is as we're coming towards this original part where we're rounded, we're just taking a pause, and we're going on a detour. So, again, down to this corner, instead of rounding the corner, we're just doing a bunch of stuff. It just happens that this stuff here is another monolinear, it's my main heritage coming out, monolinear Sona. So as I exit the original Sona, I go on this particular circumnavigation of this grid, which I know can be accomplished in one pass. I only need one pass to do it. And then I come back, I've done everything, as opposed to this one, where when I go through that grid, I know I'm not going to do everything. It takes more than one curve to fill this grid out. So I'm not going to be able to do everything in one pass, which means I'm going to have at least one extra component. Over here, when I'm diverted and I trace out my path, I end up back to where I started, having done everything that I needed. I don't need any additional curves here. By contrast, let's take a quick look at this before I wrap this video up. So now this is mono. And the idea is, there used to be this sort of W shape, right, that we had before, and also this inverted V shape. There are sort of 2 pieces of this 2x4 Sona. And what we're doing is we've joined everything up. So part of this V shape get joined up with this inverted V shape, and then this inverted V shape get joined up with this inverted V shape, and talking's not going to help. Overlapping at one point only connected one component of the 2 that each of these had. Overlapping 2 here connected both. So we reduced. We went from 2 to 1. All right, and then kind of quickly over here, and this is remains monolinear. All right, let me pause the video right here.